We've selected Lockheed Martin Aeronautics Company to design, build, and test the low-boom flight demonstration supersonic experimental aircraft, or X-plane, that reduces a sonic boom to a gentle thump. Work is expected to last through December 2021, followed by flights over select U.S. cities starting in mid-2022 to collect data about community responses to the flights.
We are surrounded by sound every day. From household sounds like dogs barking and people talking, to noise pollution from highways, industry, and planes, our days have gotten very noisy. NASA is working to reduce some of these unwanted noises. As a leader in aeronautics research, NASA is working to reduce the sounds produced by aircraft. The Low Boom Flight Demonstration, a NASA aeronautics mission, includes the design, building, and testing of the X-59 Quiet Supersonic Technology Aircraft, or X-59 Quests for short. The X-59 will be able to fly at supersonic speeds, faster than the speed of sound, without producing a loud sonic boom. But what is a sonic boom? A sonic boom is the thunder-like noise a person on the ground hears when an aircraft or other type of aerospace vehicle flies overhead faster than the speed of sound or supersonic. Picture an aircraft flying through the air. As the aircraft moves, it pushes air out of its way, continuously creating sound waves. These sound waves, or air pressure waves, move away from the aircraft in all directions at the speed of sound, like ripples that form by dropping a pebble in a pond. By increasing the aircraft speed to supersonic, or faster than the speed of sound, the air pressure waves begin to pile up ahead of the airplane and compress, forming shock waves. These are similar to waves that pile up in front of a boat as it moves through water. In the air, the shock waves will move out and away from the aircraft. This creates a sudden change in pressure. The change happens so quickly that when the energy from the shock wave reaches our ears, it's heard as a loud crack of a sonic boom. So how is NASA trying to quiet the sonic boom with the X-59? Let's find out from an X-59 NASA engineer.
Well, the X-59 is designed to generate a quiet sonic boom when it flies supersonically. Traditional airplanes that fly supersonically, such as the Concorde or military jets, develop a very loud sonic boom as they fly over the ground. It's very disturbing to people on the ground, and that's a big impediment to being able to just fly commercially all the time supersonically. So this airplane is a demonstration of a capability that we think we developed to be able to shape the airplane such that it will not generate that loud sonic boom. And so if you look at a picture of the airplane design, you'll see that unlike a normal airplane, it's very long and slender. And the reason for that is to be able to shape the volume distribution and the lift distribution over the airplane in such a way that the shocks don't all coalesce into a very strong front and rear shocks that make that loud sonic boom. The airplane is designed to fly at a higher altitude for a number of reasons, one of which is the distance away from the ground reduces the noise from the sonic booms. So higher, farther away, it would be quieter. The other is, of course, that the airplane is designed such that the lift distribution over the airplane is what we need at a given angle of attack. And the angle of attack is the wind angle going into the airplane, how it touches the airplane. And so to get that angle correctly at the Mach number we want to fly at, puts you up at 55,000 feet, mid-50s. So the biggest challenge historically has been just in the capability of being able to analyze how the airplane is going to act. We've recently developed the tools to be able to predict how the sonic boom will be produced on the airplane and to be able to trace that to features on the airplane. And then that allows us to design the airplane like you see in the picture, the long, slender airplane that then develops the quiet sonic boom.
Finally see it coming together is just so exciting, and I'm excited for first flight and to see all that hard work and see all the graphics, everything come together. It's going to be awesome. Yeah, I definitely have the coolest job in the world.
This is our X-59 sim lab. The X-59 project is, can we fly supersonic without making much of a boom on the ground and set standards for quiet supersonic flight.
The cockpit is going to be exactly like the inside of the actual aircraft. We want the pilots to be able to train for any emergency procedures or whatever they need to do before they actually fly the aircraft, so they're familiar with the views of the aircraft, what it looks like to fly it, what their kind of visuals will be, what they can use to help them. Also, we're putting the wings in to limit how far down they can look from the aircraft. We don't have a forward-looking window, we have a camera. When you train for emergency procedures, maybe that will require a landing without that forward vision system. The switches and the dials and knobs are as close to the real thing as we can get it, and are located physically as close as we can get it, including the throttle, the landing gear, everything. Instead of having to read all the labels or read all the switches to figure out what it is that they need to do for a specific emergency procedure, they'll have their muscle memory trained.
The first time when I see that X-59 flying, vea, va a ser increíble. Va a ser un momento super especial. It's going to be fantastic, a moment filled with joy and pride.
flights over land at speeds above Mach 1.
With X-59, we plan on keeping those accident rates incredibly low. Non-existent is what we're shooting for, and I think we're just about there. Here we are getting very close to X-59's first flight.
forward. Over in. Keep going up. Right like this. Up. Go. Move forward. Go. That's it. Good. You got no weight? 460. Same on this side. Oh, yeah.
NASA is taking a huge leap to address challenges associated with supersonic air travel. One of those is reducing the disruptive sound to people on the ground caused by supersonic flight. NASA's Quests mission is the culmination of decades of research and is centered around a new aircraft called the X-59. NASA has contracted with Lockheed Martin Skunk Works to build a new full-scale X-plane to help solve one of the most persistent challenges: the sonic boom. Since 1973, the FAA has banned commercial transportation from flying at supersonic speeds. The ban was in response to the thunderous sound of a sonic boom, caused by shock waves created when an object travels through the air faster than the speed of sound. The Quests mission has two goals. First, design and build a unique shape that will reduce the loudness of a sonic boom reaching the ground to that of the sound of a closing car door. And second, once built and tested, fly over a number of U.S. communities to gather data on human responses to the sound generated during supersonic flight to find out if the noise is acceptable to the public. Then, hand over the data from communities to federal and international regulators to help establish a noise standard for overland supersonic flight. Researchers understand that there is still a need for the development of full-scale piloted X-planes to help close gaps in our understanding of aeronautic principles. The team will soon kick off a series of X-59 flight tests that could assist in opening new markets for faster air travel over land.
Everyone joining us here today and via live stream, welcome to Palmdale, home of the legendary Lockheed Martin Skunk Works. I'm Eric Fox with Lockheed Martin Aeronautics, and I'm proud to be your MC as we unveil the newest experimental aircraft we have been developing for NASA. We're pleased to have with us today distinguished guests: Pam Melroy, NASA Deputy Administrator; Jim Free, NASA Associate Administrator. Don't be afraid to stand up and do a little queen wave. It's okay. We're all pulling for us. Dee Dee Myers, representing Governor Gavin Newsom. Palmdale Mayor Austin Bishop. State Assemblyman Tom Lackey. And representing State Senator Scott Wilk, Jack Danielson. And finally, Greg Ulmer, Executive Vice President, Lockheed Martin Aeronautics. And many other government, Lockheed, and NASA guests. For 80 years, the Skunk Works team has innovated to develop state-of-the-art capabilities in aircraft. It is an honor to be here with you today to witness a new chapter of this history as we celebrate the rollout of the X-59, a truly unique and revolutionary aircraft, which is just behind this curtain. I know you all want to see it, and we'll get to see it, but there are a few people who are eager to meet you first. At this time, I'd like to welcome our host, Vice President and General Manager of Lockheed Martin Skunk Works, John Clark.
Thanks, Eric. So, good afternoon, ladies and gentlemen, and welcome to the rollout ceremony for the X-59, a one-of-a-kind supersonic X-plane designed and built right here in Palmdale, California. It's rare that we have the opportunity to host this many visitors at the Skunk Works, and it's even more rare that we're able to publicly unveil one of our aircraft. Today we are witnessing history as we roll out the X-59, a unique experimental aircraft designed to quiet the supersonic boom. I want to emphasize the significance of this project and the genuine passion that drives our team at Skunk Works. Skunk Works has been a home of mine for nearly the entirety of my career. I consider myself extremely fortunate to work in an environment that fosters innovation and relentlessly pushes the boundaries of aerospace technology. The X-59 has the potential to shape the supersonic travel over land, cutting flight times in half of what they are today. But the X-59 is not just about cutting-edge advancements. It represents the best of our collective team and our unwavering commitment to make a positive difference in the world. I'm truly honored to be a part of this incredible journey surrounded by the best and the brightest of our industry. We're thrilled to take on this challenge alongside our suppliers and NASA, who has been a great partner along the way, whose quiet supersonic mission has the potential to transform commercial travel for the future. Across both teams, talented, dedicated, and passionate scientists, engineers, and production artisans have collaborated to develop and produce this aircraft. This project is just one of an example of the broader ingenuity of our team as we continually strive to push the envelope of what's possible. I'm thrilled that you're all here today as we unveil the X-59 and celebrate this very significant program milestone. Thank you.
An aircraft like this does not come together overnight. It takes years of collaboration with a dedicated team, a team willing to overcome unprecedented challenges and challenges that require leadership with vision. It is my pleasure to introduce Executive Vice President of Lockheed Martin Aeronautics, Greg Ulmer.
Thanks, Eric. Deputy Administrator Milroy, distinguished guests, ladies and gentlemen, and everyone with us today via live stream around the world, thank you for joining us. It's a pleasure to be here today at our renowned Lockheed Martin Skunk Works facility to celebrate the X-59, an experimental technology demonstrator that has the potential to completely revolutionize aviation. Put simply, today we are all witnessing a defining moment in aviation history. And the Skunk Works mantra of quick, quiet, and quality takes on a whole new meaning as we usher in the hopes of a new era of quiet, supersonic travel made possible through our collaboration with NASA. Lockheed Martin and NASA have partnered since the agency's founding in 1958, pushing the boundaries of scientific technical limits to explore the unknown and advance both civil aviation priorities as well as those in support of our national defense. Together, we've collaborated to support all 22 NASA missions to Mars. We've developed X-planes together, and we've accomplished many aviation firsts together. And we developed those developments have had widespread impact for both our nation and the world at large. And today we celebrate another breakthrough as we roll out the X-59, an X-plane that will shape the next era of supersonic flight. Over the last decade, our teams at both NASA and Lockheed Martin, as well as with our suppliers, have been working diligently to mature the technology necessary to get to this moment in time. I am continuously impressed by the team and the innovation design and advanced digital engineering techniques that went into the development of the X-59. The team used advanced manufacturing techniques such as augmented reality, robotic drilling, and 3D modeling work instructions to help condense aircraft assembly times. We all know that designing and producing a one-of-a-kind aircraft is never an easy feat, and the X-59 is certainly no exception. The entire X-59 team leaned into the expertise of both legendary organizations, NASA and Lockheed Martin, to ensure success for this program. And I am extremely proud and humbled of the entire team to make this historic moment possible. With the first flight on the horizon, I know there is much more work to do, but I hope everyone in this room, everyone who put all their elements together to be a part of the success of the X-59, that we pause and take a moment to reflect on all the work that has been accomplished in this important milestone as we're here today to celebrate. This is a moment future generations will look back upon with both awe and admiration. On behalf of the Lockheed Martin Aeronautics team, we are extremely proud to support NASA in making flight quieter in the Quests mission. Congratulations to our NASA teammates, to Lockheed Martin, our talented and dedicated suppliers, for your commitment to delivering the X-plane that will truly revolutionize supersonic flight, and proving once again that with a mighty, joint, committed team, anything and everything is possible. Thank you.
It's absolutely inspiring to see how the X-59 team worked together and how much it means to each person who worked on this airplane. Please join me in welcoming NASA's Associate Administrator for the Aeronautics Research Mission, Directorate, Bob Pierce.
Thank you. It's great to see everybody today, this afternoon, as we celebrate this really momentous occasion. And I admit it's a challenge to take our focus off what we're about to see, the X-59, the centerpiece of our Quest mission to explore quiet supersonic flight over land. But just for the next few minutes, allow me to expand your focus to a journey of scientific and technical discovery that got us to where we are today. This journey actually began in 1947, when the era of supersonic flight started right here in the California high desert with test pilot Chuck Yeager and the X-1. It soon became apparent that the sonic boom, a sharp, thunderous sound heard when an aircraft flies overhead at supersonic speed, was going to be a problem. When the Concorde started to fly in the 1960s, ushering in supersonic passenger flight, concerns about the boom remained. And in 1973, commercial supersonic flight over land was banned by enforcing a speed limit. But we continued to study the science of supersonic sound, gaining key knowledge about how sonic booms affect people and how to reduce their volume. The new century brought a boom breakthrough. Innovative ideas, advanced simulation, ground and flight testing showed us it was possible to design an aircraft that would produce a soft thump instead of a sonic boom. Is the thump quiet enough to allow supersonic flight over land? Our laboratory studies would say yes, but the real answer can only be found by engaging the people who would hear it during daily life, and that's the job of the X-59. After a test phase, the Quest mission will fly over the X-59 over U.S. communities, collect data from the people below, determine if that sonic thump is acceptable, and then turn the data over to U.S. and international regulatory authorities in hopes to then lift that ban. But look, to be acceptable, supersonic flight must also be sustainable. Takeoff and landing airport noise shouldn't be louder than regular subsonic aircraft. High altitude emissions should have minimal or no long-term impact at the higher supersonic cruise altitudes. Efficiencies while in cruise mode must be significantly increased, and sustainable aviation fuels will reduce emissions further. At NASA, we're pursuing the key knowledge required for sustainable air travel at any speed. In closing, what we're about to see represents a nearly 100-foot-long step forward in the journey of discovery that began decades ago, a step toward opening the door to sustainable commercial supersonic flight over land. And while I have a few seconds, I just wanted to thank the NASA and Lockheed teams. I've had the pleasure and the privilege of watching them work, of visiting them, talking with them, and working with them. And that video you saw, the dedication you see, the excitement you see, the passion you see, the expertise, that's what this is all about. It's about the people behind the mission. That's what this is about. And I couldn't be prouder. And our two project managers sitting side by side, NASA and Lockheed, Kathy Baum and Dave Richardson, they work so closely together. They make this happen in their teams, and the teams that surround this are just, I can't thank you enough. So with that, thank you all for being here today.
All right, we're getting closer. Who all is excited to see an X-59? Yeah, I'll give you a B- on that. Y'all are 150 people in the world that are here live. How many people are excited to see the X-59? That's what I'm talking about. I now have the honor of inviting to the stage NASA's Deputy Administrator, Pam Melroy.
Thank you so much, Eric. It is just awesome, ladies and gentlemen, and our distinguished guests, to be here in the vibrant beating heart of what I consider the flight research and flight test capital of the world. Here in the Antelope Valley, I spent my time as an Air Force test pilot at Edwards, and it was like going to an air show every day. Absolutely amazing. What better place could we be for this magic moment? I also want to welcome the aviation enthusiasts, not just those of us in the room, but literally thousands around the world who are joining us remotely from over 20 countries and over 6 continents. So you are also very welcome, and we're very happy to have you with us. Today marks a historic milestone for us as we unveil the X-59. This is really another jewel in the crown, not just of Aerospace Valley, but also a very rich history of NASA aeronautics. The first A in NASA stands for aeronautics, and we're all about groundbreaking aerospace innovation. The X-59 proudly continues this legacy, representing the forefront of technology driving aviation forward. The X-59 transcends its role, as all X-planes do, as a simple aircraft. An X-plane is a symbol of our collective ambition to redefine the future. And in this case, it's the future of supersonic travel. As we unveil this technological marvel, it's really important to understand the profound impact the X-59 holds for the aviation industry. Designed as a jet capable of breaking the sound barrier, the X-59, of course, distinguishes itself, as you have heard, with its revolutionary quiet supersonic technology, enabling it to actually transition and be used. Today, supersonic flight brings a thunderous sonic boom. Those of us who live in the area are familiar with the sound. But what that means is that's restricted across populated areas with good reason. And the X-59 is going to break that barrier. Meticulously engineered, it produces a gentle thump, a mere whisper compared to the disruptive booms of the past. So this breakthrough really redefines the feasibility of commercial supersonic travel over land. It brings us closer to a future that we can all understand, cutting flight time from New York to Los Angeles in half. As we unveil the X-59, let's celebrate the aircraft, let's celebrate the team, let's celebrate the spirit of innovation and the human ingenuity that it is embodied in the aircraft. It symbolizes our collective ability to push boundaries, to overcome challenges, to dream as humans beyond the present, and shape a future that promises progress for everyone. So embark with us on this journey into the future of aviation. The X-59 awaits. Ladies and gentlemen, are you ready to see NASA's newest X-plane? Great, me too. Well then let's see it. I'm sorry, you can keep looking at it, but I got a few more things to say. Behold, our stunning X-59. What a unique aircraft, and it's just incredible to see the ingenuity that went into it. As a test pilot, the first time I looked at the design, I went, huh. Really had some questions about that. Lots of great time with the scientists and engineers at NASA, Lockheed Martin Skunk Works, and all our other industry partners, and I was ready to go. In fact, I'm ready to climb in, but I won't do that, Nils, I promise. I think it's really also important to take a moment and talk about the challenges of sonic booms accompanying supersonic flight. We've talked a little bit about it, but this specialized aircraft is tackling it by engineering a specialized aircraft shape. What's most obvious right away is the long, distinct nose, which comprise almost a third of that 99.7-foot length. So this design is really critical in dispersing shock waves, which today, shocks are formed around the aircraft and then they merge together to give that boom. By designing it to disperse those, they never merge together. And that's how they solved this problem, which is really incredible. And then to further enhance its quiet supersonic capabilities, you can see that cockpit is positioned almost halfway down the length of the aircraft. And as has already been brought out, the forward-facing window was getting in the way of keeping the aircraft quiet. And so that's why it has no forward-facing window. It was a deliberate engineering decision from the X-59 team to make this aircraft quieter. But what's really interesting about that is we made that decision to make it quieter, but it's actually an important step forward in and of itself in advancing aviation technology while prioritizing the comfort of those on the ground. And huge challenge, right? Limited visibility in the cockpit. The team developed the external vision system, which is really a marvel of high-resolution cameras feeding an ultra-high-resolution monitor. Beyond its immediate applications for the X-59, the external vision system has the potential to influence future aircraft designs where the absence of that forward-facing window may prove advantageous for engineering reasons, as it did for us. So it's creating capabilities we haven't felt comfortable about putting in a crewed flight vehicle without first testing it. So this groundbreaking technology is really a beacon guiding us towards a future where visibility barriers in aircraft design can be overcome with this inventive solution. But the X-59's innovation, we also designed special features into the airplane, such as its top-mounted engine with a deck under the nozzle, which ensures that the shock waves don't merge behind the aircraft and create that disruptive shock below. This isn't just an airplane. This is an X-plane. It's a manifestation of a collaborative genius. And as Bob Pierce noted earlier, the culmination of decades of scientific exploration around the sonic boom. I'm really personally thrilled about this engineering marvel taking flight. And as we embark on this journey, let's celebrate the X-59 as a symbol of progress and a herald of quieter supersonic travel, which will bring us closer together as humans faster. Thank you, and please join me in welcoming NASA's Associate Administrator, Jim Free.
Thank you, Pam. Good afternoon. I try and learn every day, and I learned a long time ago, don't follow an astronaut. Now I learned don't follow your boss, and now it's don't follow the unveil of a new X-plane. So I'll stow that one away. Thanks so much for allowing us to be here, and welcome certainly to all the distinguished guests here today, and the most distinguished guests, the team that worked on the X-59 from both NASA and Lockheed Martin. NASA is committed to aeronautics innovation. Our X-plane investments show this commitment completely. It's exciting to see an X-plane in person, really is for a space guy. The X-59 is joining a long line of NASA experimental aircraft used to validate breakthroughs that change aviation forever. Even among other X-planes, the X-59 is special. Every aircraft that receives that X-plane designation has a specific purpose to test new technologies or aerodynamic concepts. These special planes push the envelope of what's possible in flight. And once they prove those concepts, they often go into museums. And that's really what makes the X-59 different. Once we evaluate its ability to produce those sonic thumps, its work will just be getting started. This plane will spend years traveling around the country to conduct community overflights. After its first test flights, the Quesst mission team will expand by thousands of U.S. residents very soon. The people we're relying on to give us honest, unbiased feedback on the X-59's noise will be the key to getting the data we need for the mission to be a success. Now my favorite part. I want to focus on the dedicated group of people whose innovative work has made the X-59 possible. Some of the brightest minds from NASA and Lockheed Martin Skunk Works make up this team. Aerospace engineers, mechanical engineers, electrical engineers, technicians, pilots, support staff, creative types, and so many more people whose hard work brought us to today. Thank you for every single moment, every single effort, and I'd like to take a moment and ask that all of you give them a round of applause. This team is the personification of perseverance. In addition to the challenge of designing, building, and integrating a brand new, one-of-a-kind X-plane, which they've met, this team overcame these obstacles during a global pandemic to bring us to the cusp of expanding our horizons into a new era of flight. This is such an exciting time in aviation, and NASA is glad to lead this historic mission through Bob Pierce and our Aeronautics Research Mission Directorate. Our innovators worked with the skilled team at Skunk Works to complete the build of this X-plane. Their work has been critical to the continued success of the mission. Entire careers, we are talking decades of people's lives, focused on supersonic research have gotten us here today. This team is continuing to build on the legacy of aeronautical research and also advance the research with different aircraft shaping like that of the X-59. Across all its aeronautics missions, NASA researches and innovates alongside with and in collaboration with our industry partners. Those partnerships allow NASA to create new technologies, new aircraft, new airspace designs, and operations. And they will help us develop community integration solutions that will make aviation more sustainable and integrated into our communities in ways that support U.S. economic growth, benefit the public with new and innovative transportation options. My sincere thanks to the team who have brought us this commencement, to the teams who will conduct these flights, to the teams who will collect and analyze the data, and to the American public who will become part of this mission. Thank you.
Thank you, Deputy Administrator Melroy and Associate Administrator Free. For those of you that aren't an engineer, that are listening to this on live stream, or you're in this room, let me just break this down for you. I weigh 240 pounds. If I were to jump off of this stage, land in a pool 25 feet back, 7 rows of live human beings would get wet when I cannonball into the water. That is currently aviation as we know it. What the X-59 does is it is a U.S. Olympic diver that you are going to see in Paris this summer. And when you see that diver go into the water, there's barely a ripple. That's what this does when it goes 900 miles an hour across the sky. It will barely make a ripple. So I know we all want to get a closer look at this incredible aircraft, but first I'd like to acknowledge one of our public servants who works to make projects like this possible for the American people. Please help me welcome Governor's Senior Economic Advisor, Ms. Dee Dee Myers.
Thank you, Eric. And let me just say, Deputy Administrator Melroy, Associate Administrator Free, Colonel Kaspers, Greg Ulmer, John Clark, on behalf of Governor Newsom and the people of California, welcome home. It's good to have you here. And let me just say, it's especially great for me to be here as my dad worked at Lockheed, including at the Skunk Works, directing the reconnaissance programs in the 80s and 90s. So on behalf of him, who still follows all this closely, who still has Skunk logo and merch, and still considers himself part of the team, again, it's wonderful to be here. And it's also a point of deep pride and personal privilege for those of us in California, because NASA's partnership with California is so important. It's larger than the partnership with any other state, and it brings tremendous benefits to our communities. An economic impact of $15 billion a year, over 1,800 proud NASA employees, and nearly 3,400 contractors and supply chain workers for a combined direct and indirect job force of 66,000 people here in our state, and more than $742 million a year in revenue. And if you've been following our travails, budget travails this week, you know how important that is. So to NASA, we simply say, thank you for the business, thank you for your trust, and thank you for this great and ongoing partnership. As Senator Bill Nelson says, NASA gets things done. Things that inspire us, things that unite us, things that show nothing is beyond our reach. And this project certainly demonstrates that, the X-59, and we're just getting started in terms of the scientific benefits that this program will unlock. The X-59 is the first and only quiet supersonic aircraft in the world, which we've heard a lot about today, and no one should be surprised that it was conceived, engineered, and built by artisans here in California, because this is ground zero, not just in the country, but in the world for innovation and exploration. We're very proud of that here. So true to that legacy, the X-59 will push the boundaries of aerospace, advancing the future of commercial aviation. If you want to dream big and create something that's never been created or seen before, you come to the Skunk Works, you come to NASA, and you come to California. Yeah. Our NASA partnership dates back to Downey, California, and the Apollo project in 1960. So it's a long and proud relationship. And the X-59 is just the latest chapter in our innovation story that always starts with the audacious declaration, we can do that, right? We can prove supersonic flight without sonic booms. That is such an exciting beginning. And now here we are, once again, inventing the future and inspiring another generation of science lovers, science geeks, and STEM students all across the country. And we know those dreams will change the future and the face of aviation. It'll captivate, motivate, and educate communities all over the country about what's possible, including time travel, sort of, right? You'll be able to take off in New York City, fly 925 miles per hour, as Eric noted, and land 30 minutes before you take off on the New York-LA route. So it's not exactly time travel, but it's still pretty cool to think about for those of us who travel back and forth all the time. So we know that somewhere, Chuck Yeager and Kelly Johnson, two heroes in my household growing up, they're smiling at the legacy that they have created and left and the inspiration that they still give us. Because it's another incredible milestone for NASA, for the Skunk Works, for Lockheed Martin, and for our partnership here in California. So we could not be more excited, we could not be more grateful to be making history with you all again, and what could be better than that? So thank you all for being here today and having me. Thank you.
Thank you, Dee Dee. Please join me in welcoming back to the stage John Clark for some closing remarks.
As we close out today's ceremony, I'd like to thank all of you, especially our distinguished guests, and for all of you that have attended virtually. On a personal level, this airplane represents an opportunity to take half of my week and make it more productive. I wish I had it 25 years ago. I literally spend about a day a week on an airplane, and it would be great to have something like this, and the people that will succeed all of us hopefully are going to have that opportunity, say 2032, 2035. And there's going to be a lot of opportunity in the future to drive new innovations with new commercial transport airplanes based on the technology we're creating here. The X-59's future is bright, and that's all due to the individuals on this team. And I specifically want to call out my skunkworks team and thank you for all the hard work and dedication that you've put into this. And to the NASA team, I really genuinely appreciate the partnership. The collaboration to make this all happen is very meaningful. Thank you.
Welcome to NASA Edge,
an inside and outside look at all things NASA.
Today we're here at Lockheed Martin's Skunk Works located in Palmdale, California.
And Franklin, I'm so excited after all these years that we've been talking about this. Now behind us is the brand new X-59 experimental aircraft. Can't wait, Franklin, to learn more about how they're going to reduce that sonic boom to a sonic thump.
Yes, Blair, you know we've been looking at Quests and the X-59 for many years. Back at NASA Langley Research Center, we've seen animations, we've seen models, we've seen it in wind tunnels, but to see it up close and personal, it is really, really cool. Today, Lockheed Martin employees and NASA employees have a Friends and Family Day so they can come on out, see the plane in person, and experience a lot of activities that they have set up here at Skunk Works. So while you wrap this up, I'm going to go ahead and talk to some of the friends and family and see what they're doing.
Awesome. And I had a chance to talk with Kathy Baum about the X-59 and why this particular plane is so important for NASA. Kathy, we are super excited to actually see the X-59 in person finally with that beautiful paint job. It's hard to believe this has come to fruition, but I was wondering, can you give me just a brief summary of the whole purpose of X-59 and what NASA hopes to learn in the process?
So we are really excited about this milestone, but the really exciting thing is the overarching Quesst mission, which is two parts. One is the design, build, and test of the X-59, show that it's quiet supersonic thump on the ground instead of the loud boom that you would get from a traditional supersonic aircraft. And then we will take that aircraft across the country to different communities, and we will gauge the response of the communities to the sonic thump and provide that information to the regulators to hopefully change the regulation that is currently in place, has been in place for 50 years, from a speed limit to a sound limit. So right now the regulation says no commercial supersonic flight over land, domestically and internationally. And so what we're hoping to do is provide the data so that they can say, if the aircraft is below this sound level, it can fly supersonically over land. And then that will open up the future of commercial supersonic flight.
So this blows my mind on two levels, right? So the first level is we're dealing with an X-plane, already mind blown. But the second is, like, for the first time, this is an X-plane mission where we actually can really understand, or that benefit will be for everybody on the ground. It means that in the future, if successful, maybe one day, I can get from the East Coast to the West Coast much quicker, or more importantly, some of those longer overseas flights can happen more efficiently, and that's a great benefit to everyone.
It's a huge benefit. I mean, spending more of your time on vacation, more of your time with your families, or even for work purposes, like being able to do a really far away trip in a day would be great. It really has the potential to make the world even smaller than it is right now. You know, make more places accessible to everyone.
Tell me a little bit about these people on the ground. Will you go out and actually give them equipment to measure the sound, or is this just pure anecdotal data where they can respond to what they're encountering?
So there will be some equipment on the ground from the project to make sure we understand what the sound level is that they're hearing. And then we will be gathering data from the communities using tools and responses from the community to gather that information, but not like community scientists, you know,
right.
But really kind of everyday person, you know, what did you think about this sound? Did it interrupt your day? Is it just a background noise that you can live with long term?
And believe me, some of the neighbors I've had, you know, you could do sonic booms over my house, I'd never hear it. But that's maybe another mission for NASA in the future. Kathy, we're actually celebrating Friends and Family Day with the X-59. And I'm wondering, what exactly is Friends and Family Day?
So Friends and Family Day is our opportunity as team members to bring in our friends and family who haven't been able to see the development of X-59. They've followed it online or when we've been sharing things on Facebook. But this is their opportunity to come in and see the aircraft and see the fruits of our labor.
Well, that's awesome, and we can't wait to hear even more from Friends and Family. In fact, Franklin's going to talk to some folks there at Friends and Family Day and learn more about the X-59.
Was, you know, what does it look like when we keep talking about how we...
Yeah, but what's the...
You know you want one of these. When you see that flying in the air, it's going to be a great day.
There were quite a few people here for Friends and Family today. They were taking pictures, they were doing 3D printing. I saw Snoopy and the Skunk Works mascot, the skunk. I also had an opportunity to talk to a few people about the technology in the X-59 and also ask them a couple of other questions just for a little fun. Have you ever heard a sonic boom?
I have.
Yes. Actually, yes. Yes, I have.
I have. Living out here, I've heard some sonic booms.
If you were to give me an audio representation of what that sonic boom sounded like, what would it be?
It would sound like boom. It sounds like boom.
Just boom?
Yeah, boom. I don't want to say quite earthquake, but definitely a little bit like something that you should be bothered by. Like I was a little concerned, and then it was like, I think that was a plane.
So you know that the X-59 is going to reduce the sonic boom to a sonic thump. What would the sonic thump sound like?
Do?
Like thump. It would sound like.
They say the sonic thump is supposed to sound like equivalent of a car door closing.
And what does that sound like?
Boom.
I believe a sonic thump sounds a little bit more like.
I don't think I heard
that,
it.
did you? That's exactly it.
Okay, good deal. So you know the X-59 has not been named yet. If you were to name this X-plane, what would that name be?
It's a good question. I don't know what I would call it.
Ooh, probably Spike. I would call it Silent Thunder. Silver Surfer.
The Thumper has a great ring to it. Thumper.
Yeah, Thumper. We'll go with Thumper.
You know, I'm a bit of a nerd, so I might say Excalibur because it's one of one, right? You know, and it's so special. The amount of effort that it took to make this X-plane, it really is something that only one group of people could really do by coming together. So I think Excalibur would be a great name, honestly, for this.
If the X-59 were being made into a movie, who do you think would play your part?
Beyonce.
Of course.
Yes, of course. Thank you.
Michael Richards, probably. You know, Kramer from Seinfeld. It's I'm not an elegant person.
You know, I could go with somebody really popular right now and be like, oh, Michael B. Jordan. But, you know, I don't know if I look that good. I'm going to have to say like Michael B. Jordan or something.
I would have to say Issa Rae.
Boom! I was about to say it. I don't want to insult you or anything like that, but I thought of you. I looked at you. I said, Issa Rae.
You know, people always say I look like Russell Wilson. So, you know, let's say his first stint in acting could be portraying me, you know, in a small role in X-59.
I would obviously play my own part. Actually, I don't hire out. I would play me. Yeah, I don't know about everybody else though.
We got a lot of really great answers from both NASA and Lockheed Martin's friends and family. And speaking of Lockheed Martin, Blair spoke to Dave Richardson about their role in building this great plane.
Dave, I know Lockheed Martin has worked on a lot of X-planes in the past, but tell me a little bit about the challenges it took to build this plane that will actually mitigate a sonic boom.
I think the biggest one was really waiting for the technology of advanced computers and computer speed to catch up to the science that was actually developed more than 50 years ago by NASA on how to make something low boom. The iterative process that is needed in order to change and massage the shape of the airplane, if you'd done this 40 years ago, we would have had to manually do that in a wind tunnel, and it would cost tens of millions of dollars and tens of years to actually iterate that. Whereas now, with the advent of software that can model it and the computers that can chunk through that fast enough, we're able to do those iterations basically in months. It still doesn't take hours, it still takes months as we iterate on them. Another significant challenge of building X-planes or one-off airplanes is that you only build one of them. And unlike production runs like F-35, F-16, F-18, if something comes up during the assembly or during test where a part breaks or is damaged and we need a new one, there's not another airplane in the queue for us to go and borrow a part. And so there's a challenge with that. There's a challenge with suppliers and others. When we ask them to build one thing, they make the money in making a lot of things. And so it is hard for them. And there are challenges when it comes to just making one of something.
And I guess that's why you use test pilots, because when it's this unique instance, you need somebody with a lot of extra skill as they experiment with flying that plane.
Yeah, the X-59 is actually pretty easy to fly. As you fly it in the simulator, you don't see all of the smarts that went into the flight control system. But because the airplane is so long, and there's some unique things about just the dynamics of that structure, it's sort of like a diving board. It does bend and it moves and flexes in flight. We do have very narrow limits on how much you can pitch the airplane up or down or side to side. And so again, we have the best pilots that are in the world, and they are just practicing. But it is a unique airplane, and for right now, we do have just 3 pilots who are qualified to fly it.
And they're also using a new kind of X-Vision, you call it. It's the ability to fly using a forward-facing camera. Tell us a little bit about that.
So if you remember going back 60 years to Concorde, you'll remember that the nose of the airplane drooped. It drooped because the pilots couldn't see over that long, skinny nose. You wanted that long, skinny nose and that fairing over the cockpit to make the airplane more aerodynamic. We have a really, really long nose. We can't make that nose go down when we're coming into land. The other thing is we couldn't afford to have a canopy in front of the pilot, so a windshield for him to look out on. That created a huge shock and made the airplane much louder. So we have this external vision system, which NASA developed. It's a key enabler really for the program. If you really want to look and say, well, what are the technologies that make this happen? We talked about the advent of fast computers and the software to model the shocks. But the external vision system is the other key element that's required in order to make this airplane happen. Without it, it wouldn't work. We have the vision system that looks forward, but when we do come into land and that nose comes up, that camera's blocked. And so what we have is a little trapeze that comes down, and there's another camera that looks and we can see the runway. So the pilot really does look at this, computer screen, if you will, a very high fidelity one right in front of him.
That's amazing.
It is amazing.
Yeah, I love it. Now, one thing I have to ask you about is the paint job. When I saw that for the first time, I'm like, this is the most unique kind of matte finish, right?
Yeah.
I expected glossy, but I saw this matte finish and I thought, it looks really good. Was that just an aesthetic choice?
No, it wasn't. Here we're in the hangar up at Armstrong, and you look at the F-18, the other planes, they have this nice glossy paint. And originally we thought that's how we're going to paint the airplane. What we do with the X-59 is every little detail on there actually makes a shock that contributes to the loudness of the boom. And on the trailing edges of a lot of wings of normal airplanes, you have these little wires that stick out. They're static discharge wire. Like when the airplane goes through the air, it's like you rubbing your feet on the carpet, and it creates static electricity. The paint that we have on the airplane makes it so that we don't have those static discharge wires. It makes it so we don't create that static electricity. So think of putting like Teflon on your shoes, if you will. But it does look different because it's not shiny, and because of just the way the paint is, it's very unique. It has a conductive property to it, but we don't touch it. It's one of those things that just likes fingerprints and things like that, so we do baby the airplane.
Well, that's smart anyway, especially with me around. You don't want me going up and checking it out.
I always want to touch it.
I know. I could see myself just reaching out. You know, you want to do it, but that's awesome. Thanks, Dave. This was fantastic information about the X-59. And we're going to learn even more facts about this great plane from Franklin at Family Day.
So we're going to start off. I'm going to ask you a few questions, and then we'll have some follow-up questions, and it'll be kind of like a discussion. Okay? First, can you tell me a fun fact about the X-59?
Fun fact about the X-59 is it's just a couple of inches shorter than 100 feet long.
Of the close to 100 feet, the nose is 38 of it.
It's using the landing gear off of the F-16, but the airplane is almost exactly 2 F-16s long. So you took the landing gear off of a short plane and you stuck it on an airplane that's twice its length.
The X-59 will fly at about 55,000 feet.
Okay, now I'm going to give you some of my fun facts, and we'll see if you can answer some follow-up questions that I have about the X-59. Ready to go?
Yes.
The new plane is called X-59. What does X-59 stand for?
Experimental.
Experimental, I mean, 59 doesn't stand for any, that's the 59th X-plane.
This is the 59th X-plane, yes.
The 59th X-plane.
Now, when I first saw the X-59 in person, I was like, wow. What was your expression like?
The nose is way too big. Way too big. Anna, don't judge him. It feels like the nose is gonna fall right off.
Okay, all right. The X-59 is roughly 100 feet long and about 30 feet wide, the size of a basketball court. How many LeBron Jameses can you fit inside the X-59?
I'd say 30. Like,
This is a trick question?
10.
10, all right.
Dad?
Well, if he wants to stay in one piece, 1.
So NASA uses an external vision system, which is comprised of computers, sensors, and HD monitors to ensure safe navigation. This replaces the standard window on an aircraft. If the front-facing view is called an external vision system, what is the rear view called?
So then maybe the internal vision system?
Maybe the back external vision system?
I don't think there is a rear view. I don't think there is.
I don't think there's a rear view because why would you need to see in the back when you're flying forwards?
Lockheed Martin, who built this plane, did so in their skunk works here in Palmdale, California. Their mascot is a skunk. What would your mascot be?
Has to be Pilot Snoopy.
Maybe like a cloud, but with like a face on the cloud.
Maybe like Neil Armstrong or like a rocket or a plane or also Snoopy.
This is the final question. The X-15 holds the speed and altitude record for a rocket plane at Mach 6.7 in 354,000 feet. Neil Armstrong flew the X-15 7 times. How many times did your family member fly the X-59 virtually?
0. Probably 0 times. 0.
Dad?
2 or 3.
2 or 3? Okay, good deal.
0. I'm pretty sure that it's 0 also.
Both wrong. I've flown the X-59 virtually many times and I've successfully landed it. So it's not that hard to fly actually.
It truly is a special thing to see the friends and family and all the people that contributed to the making of this great plane together in one place enjoying themselves. Earlier, I had a chance to ask Kathy and Dave about what this event meant to them and the project as a whole.
It's not just the team members who are contributing to this project. It is also their friends and their family. The support that they get from those people is so key to them being able to achieve their job and to contribute to X-59.
Actually, this week marks 32 years for me at the Skunk Works. Over 25 years of those were spent in black programs. My kids grew up not knowing what it was that I was doing. This has been a dream job and a dream career for me. But I couldn't show people what I did. I couldn't tell my dad and others who love airplanes as well. But the X-59 is unique, it being an unclassified program, and also the NASA desire to really be very public about it, to get the public excited to participate in the community response, has allowed me and those who work on the program at the Skunk Works to be very open with what we're working on.
There are a number of people who have traveled a lot for this project. There are a lot of sacrifices, long hours, weekends, missed birthdays, missed anniversaries, you know, those type of things. And this is friends and family's chance to really see what they have actually been contributing to, because the support that they've been given their team members has been really important to the success of this team.
You know, we all get on airliners, we all get in our cars, we all drive on freeways, we all have our cell phones. There's a lot of science behind all those things, and there's a lot of engineering, and there's a lot of manufacturing know-how, and all these things all combine to make things that you think are impossible, possible, or those things that people say it can't be done, actually make them real, which is what we've done with the X-59. This is something that everybody thought was, you can't do that. And so next time you're watching a movie and the credits come up, pause and think about that, about the army of people that were required to make that movie that you enjoyed or hated.
Yeah.
But the same thing exists for the X-59. There's an army of people in suppliers, people at Lockheed, people at NASA that have enabled the airplane from just how smart they are to just their ability to solve problems or to get the funding, to just get roadblocks out of the way. And so yes, it's a big deal to have this family and friends to be able to share it and have those credits go by.
Test, nose wheel steering on and clear proceed, card 1, step 2, clear to taxi.
What is NASA known for? What would most people say? The answer may not surprise you. Most would undoubtedly speak about NASA's past and present space flights and recent developments of new technologies and breakthroughs in science. While NASA does focus much of its efforts on projects that are outside of our home planet, much of NASA's research and development is performed closer to home. The first A in NASA stands for aeronautics, and that focus on aeronautics is just as strong today as it was in the past. Looking back to the early history of NASA and its predecessor agency, the NACA, much of the pioneering work in aeronautics was carried out by experimental aircraft that later became known as X-planes. X-planes are a series of United States aircraft and rockets used to test and evaluate new technologies and aerodynamic concepts. The X designator denotes the unique experimental research mission. For decades, these unique aircraft flew around California's high desert, pushing the envelope of flight mechanics and providing a solid foundation for our understanding of aeronautic principles to help solve major aviation challenges. X-planes and other prototype air vehicles hold a special place. They're a glimpse into the future of what supersonic aircraft and spacecraft may become. Over the last 7 decades, they've been a proving ground for developments, including delta wings, tailless aircraft, and supersonic flight. Vehicles that fly at supersonic speeds are flying faster than the speed of sound. The speed of sound is about 760 miles per hour at sea level. These speeds are referred to by Mach numbers. The Mach number is the ratio of the speed of the aircraft to the speed of sound at altitude. Flight that is faster than Mach 1 is supersonic. Supersonic includes speeds up to 5 times faster than the speed of sound. or Mach 5. From the first flight of the X-1 in 1947 all the way through X-plane flights in the early 80s, NASA and the military have built many X-planes that help challenge and change our understanding of aeronautics. Eventually, the emergence of advanced computing coupled with constrained budgets helped slow the development of full-scale X-planes and led more to the use of smaller, uncrewed aircraft for testing. But even with computer simulations and small unmanned aircraft proving to be powerful tools in the development of new aircraft, researchers understand that there is still a need for the development of full-scale, piloted X-planes to help close gaps in our understanding of aeronautic principles. The Lockheed Martin Skunk Works team, contracted by NASA, has built a new full-scale X-plane called the X-59. This new mission, called Quesst, has two goals. First, design and build a unique shape that will reduce the loudness of a sonic boom reaching the ground to that of the sound of a closing car door. And second, once built and tested, fly over a number of U.S. communities to gather data on human responses to the sound generated during supersonic flight to make sure the noise is acceptable. NASA plans to hand over this valuable data from communities to federal and international regulators to help change the rules. If successful, this could lead to a new generation of commercial supersonic aircraft operating over land, clearing the way for time-saving, faster flights for the flying public. We will speak with researchers on the cutting edge of this technology to explain how this type of aircraft will be built and utilized, and how this aircraft has the potential to be the pathfinder for supersonic commercial aircraft of the future. And we will follow the X-59 team as they move from the testing and validation phase all the way up to the first test flight of this new X-plane. That sound is well known to military personnel and citizens who live close to certain military bases. But supersonic aircraft have been around for many years. In 1947, Chuck Yeager became the first person to fly faster than the speed of sound, around 760 miles per hour. Since that time, many military aircraft routinely fly past the speed of sound.
But soon after sonic booms became a regular thing, the military advanced very quickly to having supersonic capable aircraft. And then really very soon after that, we began to see the ideas for supersonic airliners. So it was really very exciting, and it really had a lot of possibility. But the military, where sonic boom first was kind of a novelty, it pretty rapidly became apparent that on a large scale basis, the noise was just not going to be acceptable.
A sonic boom is heard after an aircraft breaks the sound barrier. And in fact, it can also be heard on the ground all along the path the airplane travels.
Well, basically, when you go above the speed of sound in an aircraft over land and even over water, you generate a sonic boom. So essentially what's happening is that the air just can't get out of the way fast enough of the airplane because it's going so fast. And so it generates a shock wave. And the shock wave propagates down to the ground, and it sounds like almost like an explosion or a loud boom, and it can startle people, it can rattle windows and cause problems. So for this reason, commercial supersonic flight is basically banned over land. Even military flights are restricted in certain areas because the shock waves can cause so much disturbance on the ground.
Up until about 20 years ago, there was one commercial aircraft that did not fly over land, but did operate at twice the speed of sound over the ocean between Europe and America. This supersonic jet was called the Concorde, and first arrived on the scene in 1969. The Concorde was so fast that a passenger could take off from Europe at sunset and outrace the sun in time to land in the United States to see the sunset again. Initially, it was believed that the Concorde could be used for overland flights as well, But that thought quickly changed with the realization that all the communities within the Concorde's flight path would be subjected to a sonic boom. So in 1973, the Federal Aviation Administration issued an order banning supersonic flight over land, leaving the Concorde to only fly over the ocean. Finally, in 2003, high expenses and limited flight routes forced British Airways to retire the aircraft for good. Fortunately, the decades of flights by the Concorde didn't go unnoticed.
And so with the Concorde, we learned a little bit more about sonic boom, and then we also learned a little bit more about some of the environmental challenges and the airport noise challenges that went along with that, and economic challenges and so on. The last flight of the Concorde, we really realized that we'd have to have a lower boom type configuration that would be more feasible for a commercial airplane. Today, I think we have the advantage of many things. A lot of our tools and technologies that we've developed along the way. Some of those computational tools, for example, are much stronger, and our computing speeds are much faster, where we can sort out these sonic boom challenges. We've also learned a lot more about sonic boom shaping of the airplane.
So it's really interesting to see the evolution in recent years, in the last decade or so, in our thinking about how to design a supersonic airline. I mean, the math has been around since the 70s. And as a matter of fact, Christine Darden, one of the hidden figures that didn't get into the movie, was really one of the mathematicians that helped define that theory.
The Russians, the English, and the French, and the United States were all going to build a supersonic transport. In '71, the United States had done some flight tests over Chicago and Oklahoma City, and they got so many complaints about the boom and calls and cracked windows and so forth. The United States canceled their SST program. My boss walks into the room as my first assignment. He hands me a technical paper from a couple of professors at Cornell University on their thoughts of some ways to reduce the sonic boom. NASA created it because people still wanted to go fast. He says, here, I want you to solve the equations in here, write a computer program for this, and if you've got any questions, I'm next door, come and ask me. Otherwise, go to it.
Dr. Darden and other NASA researchers continue to work on the issue of reducing the sonic boom over the years. But recently, a renewed interest in this field has led to a resurgence in testing.
The problem was we couldn't make a practical airplane that had the sound characteristics that we wanted. The big change that I've noticed in all these years is we went from trying to design the airplane to produce a specific sound on the ground to a process where we let the sound that we want and the airplane design evolve simultaneously. That's really enabled us to design an airplane that not only is quiet, but it also meets all the other performance requirements of a good airplane. It can take off and land, it's efficient at cruise, it performs well. So within a few years, we went from this is really hard to, hey, we could really do this. So that was very exciting in that time period.
That exciting work has led to the X-59 design. This aircraft is being purpose-built to literally shape the noise to reduce the loud boom to the sound of a quieter thump. With its unique design, including a long pointed nose and sharply swept wings, engineers and researchers believe they have a chance at beating the boom at its own game. Specific design choices would ensure the pressure waves created by the plane weaken and do not merge, preventing a traditional sonic boom.
So the X-59 is essentially like a supersonic object that might travel through the air faster than the speed of sound. So for example, a bullet could be fired. When you hear that kaboom, you're essentially hearing the sonic boom from that bullet. And there's a trailing edge and a forward edge that kind of creates that pressure wave and that sonic boom. So if you take that and apply it to an airplane, airplanes that have been designed today create what's called an N wave, or a pressure wave that is shaped like an N. So it has a sharp crack at the beginning and the end of that pressure wave. When you want a low boom airplane, you're really lowering the amplitude and you're also lowering the ramp time to that pressure wave. So it's more like a sine wave that allows you to hear a softer kind of thump feature on the ground.
So for a supersonic aircraft to be quiet, in other words, not produce a sonic boom, if you're going to do that design, you really have to take that into consideration from the very start of the design. So the airplane doesn't look radically different from other supersonic aircraft, but there are certain features that are really important.
So the X-59 is a unique kind of one-of-a-kind purpose-built airplane. So when you build an X airplane, is what they call it, there are really several things you're trying to achieve. One is technical. What are the technical objectives that you're after? So a low-boom airplane would tend to have a long nose, swept wings, might have a T-tail for stability, a canard for pitch control, and so on. So there's some technical needs to get our low-boom aircraft. But then we also, because it's a one-of-a-kind airplane, have a lot of cost needs. So we might utilize, for example, the T-38 canopy, the F-16 landing gear, GE 414 engine that goes in an F-18 in today's fleet. So there's really kind of a combination of cost features and also technical features. And then we've got some facilitating technologies like the external vision system that allow us to do the mission. So it's really kind of a hybrid of things that we have to consider in building a next airplane.
To build those features into an aircraft, NASA turned to Lockheed Martin in Palmdale, California, which is located near testing facilities at NASA Armstrong and Edwards Air Force Base.
NASA has the vision. NASA has the budget. They also have the sort of the charter, if you will, to go and do these things. So they came to Lockheed because we had the know-how in terms of some of our software tools to be able to do that boom prediction, to very rapidly iterate on what the design should look like. And so they use the talents and the knowledge base of industry. We have the industrial base to be able to build an airplane like this, the hangar and all the tools, and then the relationship with suppliers to do that. So it is kind of a marriage, if you will, between NASA and contractors. Obviously, we want to demonstrate this low boom as cost effectively as we can and as quickly as we can, but making an airplane that's very large is very, very expensive. We're using off-the-shelf parts to make this airplane possible. That limits us in what we're able to do. For instance, the engine is an F414 engine out of an F18. That gets us to Mach 1.4. We'd like to go to Mach 1.6 to 1.8, but again, we're using what we can in order to make it affordable to prove out the low boom, to have the regulation changes. We made it as small as we could, as cheaply as we could, but also it's not a stunt and it's the right size to show that you can take these technologies to an airliner.
Although NASA and Lockheed used some off-the-shelf technology, they also completely reimagined the shape of the X-59 to help assure that the sonic boom would be reduced to a thump.
I'd say the thing that's different about this airplane is how focused and purposeful it is. Every single feature on the exterior of the airplane is intentionally designed that way to meet the mission of being a low boom demonstrator. So the entire outer mold line of the airplane, with the exception of the canopy, is completely new. And we had to go through thousands of iterations using computer simulations to really refine the shape. And the devil's in the details when it comes to low boom design. So we had to carefully iterate on everything, whether it's the shape of the canard you see behind me, the nose, the way that we integrated the engine, etc. All those features had to kind of work together so that we stopped those individual shock waves from the aircraft. We stopped them from coalescing and resulting in a loud double bang. And that's the most unique thing, is how purposeful and intentional we had to be with the entire shaping of the aircraft.
Although the aircraft has not flown yet, that hasn't stopped pilots from getting flight time in this aircraft. In addition to the test pilots at Lockheed, NASA built this one-of-a-kind simulator to help prepare the pilots for what to expect once the aircraft takes flight.
The simulator is built from the same blueprints that the aircraft is being built. So this was our first opportunity, even before the airplane's ready, to get in and start looking at how it's laid out. We've already found a few minor things, gauges that we couldn't quite see or things we wanted in different places that before it was actually built, we were able to find these things in the simulator and give that feedback to the engineers. There's a lot of switches on the throttle and the stick that allow us to actuate different modes and displays. And so we get to experiment with all that here in the simulator and see that it works the way we would expect. Beyond that, we get a feel for how the airplane's going to handle. The control laws in this simulator are exactly the ones that the engineers are designing at Lockheed. We expect that the airplane should handle very much like the simulator. There will be minor differences, and that's what flight test is all about, but For the most part, we really believe that what we're doing from a handling qualities or a performance standpoint in the simulator should match the real airplane. It's a build-up approach. Initially, the engineers will power the airplane on and start to make sure that the components and subsystems are all working together. At some point, it'll be a big moment when they power up the engine for the first time and everything's working on aircraft power. Probably have the test pilot sitting in there. Eventually, we build up to taxiing around the airfield. From there, you build up to a low-speed taxi down the runway, then a high-speed taxi down the runway, and eventually we get to what's always called first flight, where the airplane gets into the air. The first flight is a very basic flight. We'll just get airborne, fly it around, make sure things seem to be working, and the real goal of the first flight is just to safely get back on the ground. And then there'll be a lot of looking at data to make sure everything worked the way it was supposed to, and then in baby steps we'll pick up the pace and then we'll start expanding the envelope from there.
As part of this testing, NASA will not just be looking at the aircraft itself, but will be validating the low boom noise from the ground and from the air.
We'll be testing at Edwards Air Force Base. We'll have a 15 to 30 mile array of recording equipment on the ground that will capture, as we do a pass with the aircraft, will capture the acoustic levels on the ground that you would hear. A sonic boom stretches for a very long distance. What we call the carpet underneath could be something between 20 and up to 100 miles, depending on the atmosphere that day. We also have a glider that will be flying at about 10,000 feet that will be doing some additional measurements in the air with a shock sensing probe. There's a lot of turbulence on the Earth. You know, you have a lot of variability, winds, everywhere. And that's a really challenging part of the atmosphere for us to model. We've done tests in the past to try to develop turbulence models, but that's going to be a big part of a validation phase, is really trying to understand that atmospheric boundary layer, which really can have a very large impact on what you're hearing on the ground. Just like we have in wind tunnels, we do something called Stellarium imagery. We've perfected a technique to actually do airborne Stellarium measurements, which basically creates a really nice picture and actually lets us see the shock waves coming off of the aircraft. So if our predictions are not matching the data we're measuring, we can use this imagery to try to understand where some of that discrepancy is coming from. So that's a great diagnostic tool for us, plus we get some great images.
Shortly after that phase of testing is complete, NASA will move on to the community overflight phase to get the public's input as to what sound level is acceptable for quiet supersonic flight.
So the main goals of the community overflight tests is to get that public response to the varying levels of the sonic thump. First of all, is it noticeable at different levels, or how noticeable is it? How annoying is it? And as we develop that relationship of the sound level to the annoyance level, we can then take that information, try to create as much of a nationally representative data set, and then provide that to the regulators that they can then use to come up with a noise limit or a noise standard to permit overland supersonic flight.
That validation will be an important factor to determine if the public agrees the noise from these new vehicles is acceptable. As we move closer to the goal of having the X-59 fly for the first time, the excitement displayed by the team is beginning to build to a new level.
The thing that excites me about this program in particular is it allows us to get aviation back on track to where it was in the first 7 decades of flying. Basically, from the time of the Wright brothers until the 1970s, airplanes got faster every single year, kind of like we expect today from smartphones or computers. If you think now back to what iPhones were like 10 years ago, it's remarkable how much better they've gotten. And aviation used to be exactly that same way, until we ran into this sonic boom problem and hit a barrier. And the barrier was really regulatory for good reason. A ban was put in place in 1973 on supersonic overland flight because it was just too loud. And no one, including myself, would accept hearing sonic booms on a day-to-day basis. And so this program, I believe, will allow us to get back on track and keep progressing, keep pushing faster and faster like we had been up until the 1970s. And that's really exciting.
I think one of the things that, obviously we look forward to the first flight. That's always a big deal. But I almost compare this airplane to, if you're a Star Trek fan, when the first warp spaceship was done. That's kind of a big deal in the Star Trek world. This is sort of analogous to that. And the airplane will fly, but at some point it's going to go supersonic and it's going to create a quiet boom. And to me, actually, that will probably be more of an emotional moment than the first flight, because that's exactly what this airplane was designed for. And when it flies over and we don't hear it, it's a success.
You need the control room full. This is going to be a verbal from the lead. Starting over here with Zeus.
Zeus, go for takeoff. ECS, go. Fuel, let's go. Prop, go.
BMS, go.
Air data, go.
F2, go.
Avionics, go.
Flutter, go.
Hydro, go.
Flags, go.
Loads, go. SR, go. TD, go.
Control is all. X-59 control is go for takeoff.
Like that. Hey! That was coming.
Years and years that it took to get to this point, and we finally crossed that milestone.
All the work and the build-up getting the airplane to this point, and then to see that take to the sky for the first time.
So when it came to game day, I wasn't worried about anything because I knew the team had my back.
It has the promise to be a historic milestone towards the next era of commercial aviation.
I've worked with so many people for so long to make this happen, to actually see it take flight. What an experience.
It's a tremendous accomplishment for all of us associated with X-59.
What we're doing has impacts on the commercial aviation industry and has the opportunity to revolutionize commercial air travel.
To go prove a concept that at one point people doubted could be done. Pretty exciting.
I never would have guessed when I was 16 years old and I wanted to be a test pilot that I'd ever have the opportunity to do a first flight, let alone a first flight on an X-plane.